Okay, this lesson is about factoring using the GCF and factor by grouping. So the first thing that we're going to start with is factoring using the GCF. And GCF stands for greatest common factor. So you're looking at the greatest thing that these parts have in common. So if you're looking at 8, 16, and 20, let's not look at the x's for just a minute, just look at the numbers. 8, 16, and 20, what's the biggest number that's going to divide into those? Okay, that would be a 4. And so that's part of the GCF. Now you look at the x's. This one has 5, this one has 4, and this one has 3. So the greatest amount that they share is 3. And that's going to match the variable with the smallest exponent as long as the x is in each piece. So our GCF is going to be 4x cubed. And the way that we factor, we don't just write down the GCF, you actually put a big parentheses and you write what would be left once you divide that out. So if you divide 8 by 4, you get 2. And if you take 3 of the x's out of the 5, you have x squared left. Then there was a plus, and you look, 16 divided by 4 is 4. And if I took 3 x's out of the 4, there's 1 left. And then again I have a plus. And 20 divided by 4 is 5. And I took all 3 of those x's out, so there should be no x's here. And so this is what this would look like factored when we take the GCF out. Now, sometimes you can factor these trinomials, and we're going to save that for a different lesson. Right now we're just going to focus on the GCF. Okay, if we move on to number 2, again, this one just has 2 pieces. It's a binomial. So we look at the 10 and the 25 first. What is the biggest number that's going to go into both 10 and 25? And that would be 5. Then I look at the y's. Both pieces have y's. So I'm going to go with the smallest exponent, which is the 2. And so y squared is what I'm going to take out. And so this is my GCF. Now I put my parentheses and put what's left. So 10 divided by 5 is 2. The y cubed was there. I took 2 out. That leaves me with 1 in. Then there was a minus. 25 divided by 5 is 5. And I took both of those y's out. So just have the 2y minus 5. So those are our first 2 examples. Let's scroll on down and do a few more. Okay, for our third example, we have a trinomial. It has 3 pieces, so I'll look at the numbers first, 45, 15, and 15. And so the biggest number that's going to go into those is 15, so this one's a little bit bigger. And then I'll look at the x's, and some of you would jump to say, hey, it's x squared, but if you look, this 15 does not have an x, and so I can't take something out unless it's in all of them because it has to be a common factor. So no x's out this time, just 15. Put your parentheses up, 45 divided by 15, it's going to be 3. I didn't take the x's out, so there's still x cubed there. And then a minus. I took the 15 out, or 15 divided by 15 is 1, however you want to think of that. And again, I could not move the x's, so I have x squared. And then a minus. And again, you can think of it as I took the 15 out, or probably in this case it is better to say 15 divided by 15 is 1. Otherwise, you'll lose that place. And you need that 1 anytime the whole piece is the GCF and you take it to the front, there needs to be a 1 here. Because if you distributed the 15 in using the distributive property and said 15 times 3x cubed and 15 times x squared, you wouldn't get this last one unless you had 15 times 1. So you need that. Okay, let me scroll down a little bit. Okay, next 2 examples. Looking at number 4, you have 35, 7, and 14. So the biggest number that's going to go into each one of those is 7. And then again, I do have y's in all the pieces this time. So I can take y out. And the exponents are 3 and 2 and an understood 1. So that'll be the smallest. So I can just take 1 y out. Open up my parentheses. 35 divided by 7 is 5. And if I took 1 y out, I would have 2 left. then a minus. 7 divided by 7 is 1, and I took one of the y's out. So I'm left with 1 inside. And then my last piece, 14 divided by 7, would be 2. And I had one y, I took it out, so there are no y's left on that piece. Close up that parentheses. And then for our last GCF example, we're looking at 6, 3, and 2. And so most people think, oh, 6 or 3, it's like they seem to be having something in common, and that's because the 3 times 2 is 6, but it's not multiplying to get the GCF. It's what will divide into those. And the biggest number that's going to go evenly into 2, 3, and 6 is 1. So we don't have a number other than an understood 1 this time. So let's look at the y's. We have 5, 3, and 2. Everything has a y, so I'm going to go with the smallest exponent represented, which is the 2. So y squared is my GCF. You do not have to have a number. Sometimes it just is a variable. Open up your parentheses. We didn't have numbers, so the 6 is still there. I had 5. Now I have 2 out front, so that would leave me with 3 on the inside. Then plus, again, the number is still 3. I had 3 y's originally. I took 2 out, so I have 1. And then the last one, keep the 2. I took the y squared out. So there is my answer. Now, we're going to move on to factor by grouping. And the reason I'm doing factor by grouping with GCF is because you have to use the GCF in your factor by grouping process. So, the way this works, if you don't remember, you recognize a factor by grouping problem because it has 4 pieces, 4 sets of things separated by pluses or minuses. That's how you're going to recognize it. And you want to group the first 2 together and group the last 2 together, and then look for GCFs that you can pull out of just those parts. So I'm just looking at these 2 to begin with, and they have an x squared as their GCF. So I'm going to pull out an x squared, and that's going to leave me with x plus 2. Okay. Then I come over here and I say, okay, what's the GCF between 3x and 6? And that would be a 3. So I'm going to have a 3. If I take that out, that leaves me with x plus 2. And because it was a positive 3, I'm going to put a plus right here. These parentheses, the x plus 2's, you want those to match. If they don't match, go back to your original problem and rearrange the 4 pieces until you can get something that matches. Although not everything is factorable, and you may run into something that doesn't factor, and you'll have to use another technique to solve or do what you're needing to do. So when they match, that's when we can use the factor by grouping. So the next step is treat that x plus 2 like it is a GCF. So they have that in common, write it out front, and then think about what's left. It's real easy just to look out front of the 2 parentheses, and that will be an x squared plus a 3. And you are actually fully factored at this point. If you wanted to double distribute or FOIL this back out and combine like terms, you would get your original problem. So you can check your answer that way. All right, let's look at number 7. And I might end up needing a little more room, but we'll try it. So with number 7, excuse me, with number 7, we have the x cubed and the minus 2x squared first, and then x minus 2 second. So again, I'm going to look first at the first parenthesis with 2 pieces that I have. What is the GCF here? That is x squared. And if I take an x squared out, that leaves me with x minus 2. When I look at the second parenthesis, you're already at x minus 2. So the GCF between those is just 1, an understood 1, and it's a good idea to write that one down. And they match just like I need them to. So again, I look at this line, and since they both have an x minus 2 in common, you treat it like a GCF, take it out, And then what's left is what's on the outside, which is x squared plus 1. Okay, and that is again fully factored, and if you wanted to check your answer, just FOIL it out and see if you get the original. Okay, moving on to number 8. So with number 8, this one looks a little different. We have this 12x and the 5x, which could be combined because they are like terms, and then you would have a trinomial. And again, I'm saving that for a later lesson, but you could do this problem that way. I'm going to do factor by grouping because that's what we're practicing right now. So I'm going to group the first two, group the second two. Notice I'm taking that minus with the 5. And again, start this process. So I have the 3x squared plus 12x. What's in common? A 3x. Take it out, that leaves me with x plus 4. And then I look here. Now these, again, they're both negative, and I want them to be x plus 4 if I can. So what do they have in common? In this case, I'm going to say a negative 5. Not just 5, but a negative 5, so that I can take that negative out. And taking that negative out makes this first piece become positive, and it makes this become positive. And it gives me the x plus 4 I need to match this piece. So then again, I look at this line. What do they have in common? X plus 4, which is what I had planned on. And then what's left? And that is on the outside. So 3x minus 5. And again, you could have got this answer by factoring trinomials if you wanted to, but we're practicing GCF and factor by grouping right now. Alright, for our last example, I wanted to throw in some different kinds of letters because in this class you may encounter some different looking questions. So this one has some K's in it. So I'm going to group and group. Again, look at what they have in common. They, in this case, have a K and an X. So both of those, but no numbers. And what's left would be X plus 10. This is again a situation where you already have x plus 10, so don't forget to put the 1 as the placeholder, as your GCF. Leave the x plus 10 alone. And now that those match, you can write it down as what they have in common as the GCF of that line and combine the outside stuff. And here is your factored answer. I just want to remind you one more time, if this doesn't work out, if this line gives you two things in the parentheses that do not match, go back to the original problem and rearrange this order. Like rewrite your problem to the side and just change things around. Maybe say kx squared plus x plus 10 kx plus 10. So like switch these middle two and see if it works. And you may get something that ends up being the same. So give that a try.